Today we are looking at the unreasonable effectiveness of pattern matching by Gary Lupian and Blaise Aguirre y Arques, published January 19, 2026. Now this paper, it really challenges that whole stochastic parrot idea by showing this, frankly, wild capability of LLMs. They can translate Jabberwocky languages, where all the content words are replaced with nonsense back into English.
Yeah.
So you could have a sentence like, he dwushed a gunk zock, and the model can figure out it means he dragged a spare chair just from the structure. The big idea here is that these models aren't just memorizing. They're using this high-level pattern matching to, well, de-blur information from these structural fingerprints. And it suggests that this kind of pattern matching isn't some cheap trick. It might be the actual engine of intelligence, a lot like how our own brains work. So that's the 1-minute summary. But let's get into the details, because if you're out there training models or, working in NLP, this paper offers a very different way of thinking about what's actually happening inside them.
Oh, it absolutely does. It sort of reframes the entire debate. We go from asking, do LLMs understand, to
asking something else entirely.
Yeah, to asking, is understanding just really, really good pattern matching? And the authors here, they come down with a pretty resounding yes.
It's a bold claim. I mean, we're also used to hearing the critiques, right? That they're just mimics, no real grounding, just predicting the next word.
The stochastic parrot.
Exactly.
Right.
But this paper argues that the statistics, the patterns, if they're rich enough, that is the grounding. The line between form and meaning just sort of collapses.
It does, and they show it. They don't just tell it. That's what I love. They use these Jabberwocky experiments. It's a stress test, really. They just rip the semantic content out of a text but leave the skeleton.
Right. The methodology is so clever. They take these normal text, news articles, legal documents, even Reddit threads, and they just swap out all the important words.
All the content words. Nouns, verbs, adjectives.
Yeah.
Gone, replaced with random nonsense. But, and this is the key bit for the technical folks listening, they keep the function words. The, and of.
And the morphology.
The morphology is crucial. So if the original word was, say, running, the nonsense word would be something like glorping. They keep that ing. A plural noun keeps its s.
So you get a sentence that reads like perfect English grammatically, but means absolutely nothing.
On the surface, yeah. The paper quotes the modified poem, Brof snunt and the got sneelt. It looks like total hallucination.
But when they fed this to a model, it just mapped it right back to the original Jabberwocky poem. Perfectly.
Which, is the first red flag for any ML engineer, right?
Oh, definitely. Data contamination.
Of course. Jabberwocky is probably the most famous nonsense poem there is. It's all over the training data. So fine, the model can complete a pattern it's seen a million times. No surprise there.
That was my first thought, too. It's not really a test of intelligence. It's a test of memory. But the authors saw that coming.
They did. And that brings us to the clean test, which is where this whole thing gets really, really interesting.
So this is where they use text that isn't famous.
Exactly. They took a dry, complex piece of text about U.S. federal law preemption, federal law overriding state law. The original sentence was something like, in the United States, federal law has priority.
Okay, and the nonsense version?
It was, in the Scott Splunk, Spraub flaint has flall over any bridge streths flaint.
Stott splink. Sounds like a Star Trek villain, but you can already see the patterns there. In the capitalized, that screams place name.
It does, and has flall over. That structure, it implies a hierarchy, a relationship of power or dominance.
And the LLM picked up on just that.
It picked up on just that. It translated the nonsense back to, in the United States, federal law has supremacy over any conflicting state law. It didn't just guess the topic, it get the specific relationship right.
That's mind-bending. It means the syntax, the skeleton of the sentence, carries so much of the meaning. The words themselves weren't there, but the shape of the whole they left behind was so specific that only one concept could fit.
That's what they call the structural fingerprint. The argument is that language is just so constrained that if you have the structure, you've basically defined a unique point in semantic space. There's only one thing that fits. The model isn't translating, it's solving an equation.
Solving for X, where X is the meaning. But okay, let's be skeptical again. The internet is vast. Couldn't that specific legal paragraph be some kind of boilerplate text that appears in the training set thousands of times?
A totally valid concern. We know these models memorize, so to shut that argument down completely, they ran the Fresh Data Challenge. They took an ESPN post and a Reddit thread that were posted just days before the test.
So guaranteed not in the training data. This is the real test of generalization.
This is it. And the ESPN example is incredible. It was about an NFL player's contract, had all these specific stats, like 88 receptions, 884 yards.
And the nonsense version masked the player and team names.
Right, Ginch and Flau for the teams. But the model saw the numbers. It saw 88 and 884 and $12 million. Those numerical anchors immediately constrained the whole problem.
It knows it's not talking about, say, baseball.
Exactly. The domain becomes American football. From there, it infers that Ginch and Flau have to be NFL teams. It guessed Giants and Eagles. Now, it got the specific teams wrong. The original was Steelers and Dolphins.
But who cares? It got the category right.
It got the category and the entire context perfectly. It understood it was about a player getting a contract extension because he was underpaid or, in the nonsense, frisked on his last deal. It rebuilt the whole economic story from just the structure and the numbers.
That's reasoning. It's not lookup.
There
It
you go.
understood the situation. But the Reddit example, that one went even further, I think.
The Dutch bacon mystery. My favorite part of the paper.
Walk us through it.
Okay, so a Redditor was asking if unbeatspec, its Dutch breakfast bacon, is safe to eat raw. In the nonsense version, the location was in the splud.
And the model's first guess was that this was about MSG in a Chinese grocery store.
Right, because the pattern is food safe to eat, and I bought it in place. Well, without more context, the model's highest probability guess landed on Asian cuisine.
A reasonable guess based on web data.
Totally. But then the authors did one tiny thing. They changed splud to the word Netherlands. That was the only real content word they added.
And that one token changed everything.
Completely flipped it. The second Netherlands appeared, the nonsense food word switched from MSG to rookvlees or ontbietsspek. The context instantly shifted from a Chinese market to a Dutch deli.
Wow. That's a perfect demonstration of the attention mechanism right there. One word, Netherlands, cascades through the whole sequence and changes the probability of everything else.
It proves that meaning is not local to a single word. It's distributed across the whole sentence. The model used that one clue to solve for all the other variables. It basically said, okay, given this structure and the word Netherlands, the only thing that fits here is Dutch cured meat.
You know, this connects so well to that old text adventure game they mentioned, the Gostak.
Oh yeah, from 2001. The whole thing is written in nonsense. The Gostak distims the doshes.
Right. And as a human, you learn by doing. You figured distim must be a verb. You try it, it works, and you've learned a rule. You're building a mental dictionary from interactions, not from definitions.
And that's exactly what the LLM did. If you just asked it, what is a dosh? It failed. It had no idea. But when they let it play the game, giving it that feedback loop of commands and responses,
It started to figure it out.
it converged on the correct meanings. It learned that glake means look, because it only appeared in contexts where looking was the logical action. It's pure distributional learning.
Which brings us to the big theoretical argument of the paper. This is a direct shot at Te Chiang's blurry JPEG of the web idea.
It really is. And they basically say, yes, it's a blurry JPEG, but you're missing the point. They argue that this kind of compression is unreasonably effective because it allows for deblurring.
Let's unpack that. Because when I hear blurry JPEG, I think information loss, artifacts, not a feature.
Think of it this way. The paper uses a great visual analogy. Imagine the word married, but it's blurred into a gray smudge. You can't read it.
Okay.
But now put that smudge in a sentence. The king was smudged to the queen. Your brain instantly fills in the blank. The smudge becomes married.
Because the context acts like a constraint. It narrows down the possibilities until only one word fits.
Precisely. The surrounding structure is a decoder key that recovers the lost information. The authors are saying LLMs have learned a universal deblurring algorithm for the entire web. They take this noisy, compressed, Jabberwocky-style input and use the structural patterns to restore it to full resolution.
So the blurry JPEG isn't a bug, it's the core mechanism of intelligence. We all walk around with lossy compression in our heads, and we use context to deblur the world.
That's the argument. And it ties right into construction grammar, the idea that language is made of these patterns, these constructions, from tiny idioms all the way up to abstract templates like subject, verb, object. LLMs have mastered these shapes. They know the shape of the data so well they don't need all the data points to see the picture.
So this leads to the most provocative question, doesn't it? Is this how we think? We like to see ourselves as logical, rational beings.
But we're really not. The paper argues our cognition is messy pattern matching, just like an LLM. If we were truly logical, we wouldn't all fail the Watson selection task, that simple card puzzle.
We can all read jumbled letters if you could write tis.
Exactly. A classical rule-based AI would crash on that sentence. It violates the rules. But a pattern matcher, our brain, it just sees the fingerprint. It de-blurs the noise and gets the meaning. Intelligence is the ability to handle the mess.
And they point out this fantastic irony in the history of AI.
The great irony. George Bull wanted to formalize thought as logic. That became the basis for all computers. Then, for 50 years, we tried to build AI using that same strict logic, Joe AI.
Good old-fashioned AI. And it just hit a wall. Was it too brittle?
It couldn't handle ambiguity, couldn't handle the mess of the real world. And the irony is we finally got thinking machines when we threw out Boole's logic and embraced the very messy probabilistic pattern matching that he was trying to fix in the first place.
So pattern matching isn't a cheap trick. It's the whole game.
It is the substrate. And we use tools like formal logic and mathematics and code to patch the holes in our own pattern matching brains. We invented logic because we're naturally bad at it.
That's a great way to put it. So the core engine is pattern matching, and logic is just a special app we run on top of it when we really need to be precise.
I think that's exactly what the paper suggests.
So, to sum this up, LLMs can read nonsense because they understand the structural fingerprint of language, which lets them decompress meaning from very sparse data. And this suggests they're operating a lot more like the human mind than we thought.
It does, and it leaves you with a really unsettling thought about yourself, doesn't it? If an LLM can reconstruct all that meaning from a stot splunk just by recognizing a pattern,
How much of our own thinking is just that?
how much of what we call reasoning is just us, auto-completing a familiar pattern without ever engaging in actual logic?
Are we all just de-blurring our own internal Jabberwocky?
Uh-huh.
On that note, we'll wrap up a fascinating paper. Thanks for tuning into AI Paper Podcasts.
See you next time.